Graphing reciprocals of quadratic functions. So yes, last class we did when you have a normal function and you graph the reciprocal. Now we have the reciprocal and we're going to graph the original parabola. So for this one, always remember that if your vertex here will be x and 1 over y, your vertex of your original parabola is x and y. So always remember that the vertex of your function is the reciprocal of your y value. So when you have the vertex at 1 over y, your new vertex is just y. Same here, except it'll open down. And remember that when you have a straight line with a bump, it's not going to touch the x-axis. When you have one that looks like this, with 2 sections, it's going to touch the x-axis once because you have one vertical asymptote. And the last one, when you have 2 asymptotes and 3 sections, you know that your graph is going to look like this or like this. And again, remember, if this is x comma 1 over y, this is x comma y. So it's always the reciprocal of your vertex. And a quick way for the last one to remember which direction it opens is it's going to be the opposite of your middle section. So if this one opens down, your original parabola opens up. So for our first example, we have a quadratic, and it's a straight line with a bump, so we should instantly know, because there's no vertical asymptotes, that there's no x-intercepts. So if we look at the reciprocal and the normal graph, the vertex of our reciprocal is at 3 and negative 1. The vertex of our normal graph will be when we flip it, so at 3 and 1 over negative 1, because we have to reciprocal and find the reciprocal again. And because negative 1 is the same as negative 1 when it's a reciprocal, because it's an invariant point, we know that this will be our vertex. Now what we have to do is we have to find the reciprocal of the points that we have. So if we have the point 2 and negative 0.5, the reciprocal of that point will be 2, and when you flip 1/2, be negative 2. So we want to plot our point there, so at 2 and negative 2. And we also have another point right here, this point and this point that we can go off of. So this point is at 4 and negative 1/2. So the point on our graph will be at 4 and negative 2. So we plot this point. Oops, I wanted to do that in green. So now all we have to do is draw our function. So the green is our normal function. For our second example, I think in your notes it doesn't have it fully drawn out. Make sure you draw in this side right here. What you have to do is you have to first find your x-intercepts, because we know where they will be because they're where the asymptotes are. So we know that we will have one at negative 1 and positive 1. So we know that our graph's going to go through that point. Now we have to find the reciprocal of our vertex. So our vertex on our graph is 0 and 1. I don't know, I wrote 4. So our new vertex will be at 0 and 1 over 1, which is still 1. So plot that point. And the last point is to find our invariant points. And they're right here when y is 1, negative 1. So they're at negative 1.5 and negative 1 and 1.5 and negative 1. All you have to do is draw your parabola through your points. And now that's how you graph f of x from 1 over f of x. And for our last example, because we have one asymptote, we should know that there is one x-intercept. And because it's on the bottom half of our graph, we should already know that it's going to be opening down. So what we're going to do first is we're going to find our x-intercept, which will be our vertex. And that point will be when we have an asymptote, so at x equals 3. Next, we'll plot our invariant points, which are at 2 and -1 and 4 and -1. Now all we do is draw our line through these points, and there's our graph. Except that was really poorly drawn. You're welcome.